In this video, we are going to learn how to use the ideal gas law and the combined gas law to solve problems. Let's start with question 6. A tank of helium gas is used to inflate toy balloon at a pressure of 1.55 times 10 to the power 7 Pascal and a temperature of 293 Kelvin. The tank's volume is 0.020 meter cube. How large a balloon would it fill at 1 atmosphere and 323 Kelvin? Let us first write down what is given to us. I have the pressure of the helium gas, which I will write as P1 equals 1.55 times 10 to the power 7 Pascal. Then I have the temperature of the helium gas, which we will write as T1, 293 Kelvin, and the volume of the tank, which is V1, 0.020 meter cube. And then we have to fill the balloon at 1 atmosphere. 1 atmosphere is equal to a pressure of 1.013 times 10 to the power 5 Pascal. So I will call this my pressure P2. And the temperature of the balloon T2 is 323 Kelvin. We need to find how large a balloon will fill it. So we need to basically find the volume of the balloon, which we will call V2. To solve this problem, we are going to use the combined gas law, which says P1 V1 over T1 equals P2 V2 over T2, where P, V, and T are pressure, volume, and temperature of the respective quantities. I need to find the volume V2. So in order to find V2, I need to get rid of pressure and temperature here. And to get rid of these terms, I'm going to multiply with T2 on both sides and divide with the pressure P2. So let's do that. Multiply with T2 on both sides and divide with the pressure P2. And when you do that, you get your final expression for V2 as T2 P1 V1 over P2 T1. Now solve this. I will substitute the value. Temperature T2 is 323. Pressure P1 is 1.55 times 10 to the power 7 Pascal. Volume V1 is 0.020 divided by pressure of the balloon is 1 atmosphere, which is 1.013 times 10 to the power 5 pascals, times temperature T1 of helium gas is 293. So after we solve this, we get the volume of the balloon to be equal to 3.4 meter cube. So this tank of helium gas would fill a balloon of volume 3.4 meter cube at 1 atmosphere and 323 Kelvin. Question 7. What is the mass of the helium gas in the previous problem? The molar mass of helium gas is 4 gram per mole. So let's first write down what is given to us. Since we have to use the quantities from the previous problem, which was question 6, I'm going to write down the values for pressure, volume, and temperature of helium gas. So in question 6, we had the pressure P of helium gas to be equal to 1.55 times 10 to the power 7 Pascal. And the volume of the helium gas was 0.020 meter cube. And it was at a temperature of T equals 293 Kelvin. Here in this question, they have given me the molar mass of helium. Molar mass is given by capital M, which is 4 gram per mole. And they want me to find what is the mass of the helium gas. I need to find what is the mass N. Now there is a relationship between the molar mass, the mass of the gas, and the number of moles N, which is given as N equals small m over the molar mass, where N is the number of moles, small m is the mass of the gas, capital M is its molar mass. So I can calculate the mass of the gas by multiplying molar mass with the number of moles. I have the molar mass capital M, but I do not have the number of moles. In order to calculate the number of moles N, I'm going to use the ideal gas law equation and come back to this part. So let's calculate number of moles N by using ideal gas law. Ideal gas law says that PV is equal to nRT, where this capital R is a constant, ideal gas constant, which is given as 8.31 Pascal meter cube per mole Kelvin. I want to find what is N. So if you want to find N, I'm going to divide by RT on both sides and write N equals PV over RT. Now substitute the value of pressure, volume, temperature. Pressure is 1.55 times 10 to the power 7. Volume is 0.020. R is 8.31 and the temperature of helium gas was 293 Kelvin. When you solve this, you get the number of moles N as 127.3 mole. Now I'm going to substitute this to calculate small m, the mass of the gas. So let's do that. Mass of the gas is molar mass, which is 4 gram per mole, times the number of moles, 127.3. And when you solve this, you get the mass of the gas to be equal to 5.1 times 10 to the power 2 gram. You get the final mass in gram because the molar mass is also in gram per mole. So when you multiply the number of moles with this, the final mass you get is in gram. You can convert this to kilogram by dividing the number with 1000. Then you get 0.51 kilogram. Question 8. A tank containing 200 liters of hydrogen gas at 0.0 degrees Celsius is kept at 156 kilopascal. The temperature is raised to 95 degrees Celsius and the volume is decreased to 175 liter. What is the new pressure of the gas? So let's write down what is given. I have 200 liter of hydrogen gas, which is the volume of the gas. I will write it as V1, 200 liter. Then hydrogen gas is at 0.0 degrees Celsius. Temperature of the hydrogen gas is 0.0 degrees Celsius. This temperature in Celsius, I will convert it to Kelvin. So I will write T1 equals 0.0 plus 273 to convert into Kelvin. So remember this rule. If you want to convert temperature from degree to Kelvin, you add temperature in degree to 273 and that will give you the temperature in Kelvin. So when you do this, I get my temperature in Kelvin as 273 Kelvin. The pressure at which the gas is kept at is P1, which is 156 kilopascal. Now the temperature is raised to 95 degrees Celsius. So I will write my new temperature T2 to be 95 degrees Celsius, which you can convert to Kelvin by adding 273 again. And that gives you the temperature in Kelvin as 368 Kelvin. And the new volume, the volume is decreased to 175 liter. They want me to find what is the new pressure P2. Whenever you have two values of volume, two values of temperature, and two values of pressure, we have to use the combined gas law to find the missing quantity. So here I want to find the pressure, the final pressure P2. I will use the combined gas law, which says P1 V1 over T1 equals P2 V2 over T2. Now I need to find what is pressure P2. If you want to find P2, you need to get rid of the volume and temperature values here. So to get rid of this term, I will multiply with T2 on both sides and divide with the volume V2. So multiply T2 here and divide with V2. When you rearrange this term, you get your final expression for pressure P2 as T2 P1 V1 over V2 T1. You leave P2 on the right hand side alone here and multiply everything here on the left hand side and write it together. If you do not want to rearrange, you can always use shift solve in this part here, in the first expression here, to get your answer. So now let's solve. I have temperature T2 as 368 Kelvin, pressure P1 as 156 kilokelvin, volume V1 as 200 liter, divide by volume V2, which is 175 liter, and temperature T1, which is 273 Kelvin. When you solve this, you get the final pressure of the gas as 2.4 times 10 to the power 2 kilopascal. Since my initial pressure was also in kilopascal and we did not convert that to pascal, the final answer will also come out in kilopascal. Question 9, challenge question. The average molar mass of the components of air, mainly diatomic nitrogen gas and diatomic oxygen gas, is about 29 gram per mole. What is the volume of 1 kilogram of air at atmospheric pressure and 20 degrees Celsius? So let's first write down what is given to us. I have the molar mass of air, which I write as capital M, 29 gram per mole. Then we have the mass of the air, M, which is 1 kilogram. Now, if you have mass and molar mass, we will be using them together. So we have to make sure that both of them have the same unit. So since molar mass is expressed in gram per mole, I will convert the mass of the air in the units of gram as well. We know that kilo is 10 to the power 3. So I will write the multiplier for kilo and I will write 1 times 10 to the power 3 gram. So mass 1 kilogram is equivalent to 10 to the power 3 gram. Then we have the air at atmospheric pressure. So we know that 1 atmosphere is equal to a pressure of 1.013 times 10 to the power 5 Pascal. This will be my pressure P. Temperature of the air is 20 degrees Celsius. We convert this to Kelvin by adding 20 to 273. That gives me 293 Kelvin. We need to find volume of air. Now to find volume of air, I can use the ideal gas law, which says that PV is equal to nRT. And I can find the volume V by dividing with pressure P on both sides. So we get V equals nRT over P. Now to solve this, I need to know the value of number of moles N. They have not given me the value of N. But I have the molar mass and the mass of the gas. I can use these two quantities to find N. We know the relationship between them. N equals mass of the gas over its molar mass. So we substitute mass of the gas is 1 kilogram, which is 1 times 10 to the power 3 gram, over the molar mass, which is 29 gram per mole. So I will use this value of N and substitute here for the volume V. So we get N is 1 times 10 to the power 3 over 29. R is the ideal gas constant, which is 8.3 Pascal meter cube per mole Kelvin. So I will substitute that for R. I will write 8.3 times the temperature, which is 293, divide by the pressure. Pressure of the gas is 1 atmosphere, which is 1.013 times 10 to the power 5 Pascal. And when you solve this, you get the volume of air V equals 0.83 meter cube.